Okay, so I'll just move to the next a little modified problem of assignment model. So that is called traveling salesman problem. So, so traveling salesman problem is basically a special type of routing problem. Okay, so it again you will have your cost metrics will be given to you, and you have to think that in a different manner. So that is one of the classic examples of operations research that is called as the traveling salesman problem. So here one more condition that will be embossed in your assignment model, that is it is something like it is a part or a person is traveling. So he has to travel to 6 different locations. Okay, he can start from any location and he can move to the next location. Okay, say for example, if I that he is starting from location A and 6 location he has to cover. So from location A, he will have the options to travel to location B, location C, location D, location E, location F, etc. Suppose he is moving to location B. If he has moved from location A to location B, then in front of him, he will have the option something like C, D, E, F only will be the left out options. That is, before going in the forward direction, he should not step back into the city A. Okay, that is from city B, if he is moving, he have the options to travel to C, D, E and F. See, for example, from B he is jumping to city D. Okay, now city A is completed, city B is completed, he moves into city D. Then in front of him the options will be C, E and F. That is, without completing that one loop, he should not step back into the older cities. So in such a way that if you are performing the assignment model, that is typically called as traveling salesman problem. Okay, this need not to be not only applicable to salesman alone, sometimes that will be applicable to machineries also. See, for example, if you are taking about some painting, so a particular color in certain sequence if you want to follow. Okay, so in that all cases you can apply this. So a part is going into a machine. So certain parts will go into certain machines and certain processing times is required. So which part if it goes first, which part goes next. That's the way if I just want to route it in terms of your cost element that comes, you can employ this algorithm called traveling salesman problem. And from the given metrics, you need to define or you need to understand that whether assignment algorithm, the Hungarian algorithm has to use and has to stop, or you need to further process into the traveling salesman condition. So here the metrics, yeah, so here the metrics will be given like this. So it is something like that. You can see over here from city to a to city is given. A salesman has to travel. So named Rolling Stone plans to visit 5 cities, 1, 2, 3, 4 and 5. So you can see he is moving from he can't move from one to one. So always if the problem is of traveling salesman, you can see that the diagonal element, okay, the diagonal element shown over there, okay, the diagonal element shown over there, okay, will be of infinite. And you can see the metrics will be, you can see the person is traveling from 1 to 3. Okay, so 1 to 3, if you want to travel, the cost associated will be 8. The same way, the same will be available in the case of, you can see from 3 to 1. So you can see the upper elements and the lower elements above your diagonal, or if you say below your diagonal, they remains the same. Okay. So the question here is that The traveling time in hours between these cities are shown. How should Mr. Rolling Stone schedule his touring plan in order to minimize the total travel time if he visits each city once a week? Okay. So this is the question. So this is a question which typically you have given to you for solving in the case of traveling salesman. Okay. Now, how do we solve it? Is the question clear? Is the ideology clear? Is the question clear to you? Yeah. Yes, okay. Yeah. So you can see the question will be like this. Now, how to proceed? See, first of all, the procedure will remain same as that of assignment. You have to apply the Hungarian algorithm. Okay, you have to apply the Hungarian algorithm, and you have to first ensure that all the conditions will have a typical assignment is available. Okay, so first apply the Hungarian algorithm and please get me the results that in each and every step we have assignments are possible. Proceed. Let me see. Did you copy the values? The infinity I am marking here because I cannot travel from 1 to 1 or 2 to 2. That is not possible. That's why I am marking it as infinite. Okay. First perform row operation. Quickly let me know the values. So this is 1, 3, 0 and 1. Next one also 4 is the lowest. So 1, 3, 0, 1. Third one 6 is the lowest. So 2, 1, 2, 0. Next one 4 is the lowest. So 0, 0, 4 and 4. Next one 5 is the lowest. So 0, 0, 6, 1 and 8 is 4. Sorry, 8 is 3. Okay.
Sir, 1, 3 is 4, sir.
Pardon me, Pa?
Row 1, column 3 is 4, sir.
Okay, right. Okay, now perform the column operation. Okay, now perform the column operation. So first column, okay, so it remains as it is. So 1, 2, 0, 0. Second column also no change. 1, 1, 0, 0. Third one, 1 is a minimum. So 0, you will have 3. You will have 2 and 3. So next also no change. It is 0, 0, 2 and 3. Next one also no change. 1, 1, 0, 4. So we have performed both the row operation and the column operation. So this is what we have got the results. So we'll try to perform giving the assignments. Okay. So try to give assignments. Is the first row single zero row? Yes. So you have to give the assignment over there. Next one, so what happens to the next one? So this has to, yeah, so but if when you are giving the assignment on the top,
no, it will be cancelled.
Yeah, that will be get cancelled. So we were here, yeah. So we were here. Go ahead. So that's zero. If we are giving the assignment, so this one will be cancelled off. Okay. So what about the next one? So next one is single zero. So you can give the assignment over there. Okay.
Which one is single zero?
Now,
third,
which one?
third row, right? Third row is
Third
single
row.
zero.
Third row is single zero. Second row, when I cut it,
Oh.
it is becomes unassigned. Okay. Third row is single zero. Fourth is not single. Fifth is also not single. We'll see column wise. First column, it is not. Second column, no. Third column, it is single zero. Give the assignment over there. When you give the assignment, what happened? This is striked off. This is also striked off. So arbitrarily anyone you can choose over here. So automatically gets striked off. If you give this, the next one will be automatically striked off. Okay, the next one will be cut off. Okay, now what is the situation? Is whether do we have assignments on every row and every column? Do we have assignments on every row or every column?
Two. We don't have row 2. But
Yeah,
from 2.
row 2 is unassigned. So what to be done? So you cannot, so here one row is completely, so one row or column. So one row slash column unassigned. So when it is unassigned, what you will do? When it is unassigned, what you will do? You have to draw the horizontal and vertical lines. Okay, passing through the zero. Am I right? You have to draw horizontal and vertical lines passing through the zero. Condition is that the lines, okay, so if I draw a line like this covers 2 0. If I draw a line like this, it covers 3 0. If I draw a line like this, it covers 2 0. Now next is my optional, that is only 1 0 is only left out. Okay, that is my optional. So I am just going for this way. Okay, I'm going for this. Okay, that if you draw like this also, I cannot say that that is wrong. Okay, that is your wish. Okay. Yeah. Then what to do? Then what to
Find
do?
the lowest in the uncut boxes and subtract it with the values, and at the junction you add it.
Okay, so you have told, so find the lowest from the unoccupied cell. What is the value? So that is 1. So 1 subtract, so 1 you have to subtract, so this will become 0. 3 becomes infinity, so infinity I have 0. 2, this is also 0, this is also 0 right now. So 1 becomes 0, so 2 becomes 1, 0 remains as it is. This 1 is also 0 right now, so that is untouched. 2 1 infinity. So in junction what we have to do? We have to add. So that will becomes 3. This is 0. Fourth one, it is 0 0 3 infinite, and it is 4. Next one also it is 0, 0, 0, 4 and infinite. Okay. Now let us try for the assignment here. Okay. So is the first row now single zero? No. Second one, no. Third one, yes. Third one is single zero. So you can give the assignment over there. So when I give the assignment, this is striked off. This is also striked off. Okay. Now what about fourth row? No. Fifth row? No. First column is no. Second column? No. Third column? Yes. So when it is third column, this is striked off. This is also striked off. So I have to give the assignment for the third column. Okay. Fourth column, no, fourth column is also not single zero. Fifth is also not single zero. Okay. So now we can go from the first row. I am arbitrarily selecting this as the preference will be given to the first rows. Okay. So when I select that, so this zero is striked off and this is also striked off. Okay, so you can see obviously that now this becomes a single zero. So I have given the assignment there. Now this is striked off automatically. Now this becomes single zero. Yeah. Okay. Now do we finish the assignment? Did we finish the assignment? So what is our assignment? Yeah, so we finished the assignment. So what is our assignment? What is our assignment? So let me check the assignment model first. Then I'll come into the traveling salesman. So assignment model is 1 to 2, then 2 to 4, then 3 to 5, then 4 to 1, and then 5 to 3. That is the assignment model. Now we will check in terms of traveling salesman. So assignment is completed. Everywhere we have provided assignment. All row and column assignment is there. Now we'll check for, okay, we'll check for the traveling salesman condition. Okay, so he is moving from city. Okay, he is moving from city 1 to city 2. Am I right? In the first step, he is moving from city 1 to city 2. Correct? Correct? Are you able to follow it?
Yes.
Yeah. Now he is now in city 2. Am I right? Now he reached city 2. Okay. Now presently he is in city 2. Okay. Now from city 2, where he is going?
4.
From city 2, he is going to city 4. Correct. He is going to city 4. Right. Now he is in city 4. Okay. Now he is in city 4. Where he is going?
Back to 1.
He is going to city 1. Okay. What happened? What happened here?
So the whole loop is not completed. So
yeah. So it violates traveling salesman condition. So it violates traveling salesman condition. Okay, he is moving from city 4 to city 1. Okay, so that basically violates the traveling salesman condition. So how to proceed? So how to proceed? So how
Sir,
to
one
proceed?
doubt, sir.
Yes, please.
Yeah, it should be 1 to 2, 2 to 3, 3 to 4, like that, sir, the model. For traveling sales.
Maybe sometimes like that, or sometimes it can start from any other locations also.
Okay.
It need not to be always like that. Okay, now let us see. Next highest figure after 0, the next highest figure also into our solution space, and we will check. Okay, so let us see. First he is moving from city 1. Yeah, so let us check. He is moving from city 1 to city 2. And as per our case, he is moved. So the next highest figure after 0, it is there. It is 1 over here. Okay, so 1 is there. So I'll take that into account and let us see what happens. Okay, we'll consider this 1 into our solution. Okay, and we'll see what happens. So he is moving from city 2 to city 3 by considering this value. Okay, by considering this value, so by considering this one, he is moving from city 2 to 3. Now he is moved from city 2 to 3. Now as per our question, as per our condition, he is supposed to move from city 3. So the lowest assignment whatever we have taken is to city 5. So 3 to 5. Okay, what happens? What happens? Okay, he can move forward, but if we see the next condition, city 5, okay, the lowest in city 5 is city 3. So he is coming, he has to come back from city 5 to 3. So which again violates. Okay, so how to tackle this? So how to tackle this? So you have to take the next highest values also into the account, and you need to try to solve. Okay, so now you have to see for this unassigned zeros, is any other way will it work? Okay,
Sir,
so
One doubt.
yes, please.
We can put 1. We can consider 1, sir. 1 is the next lowest cost rate.
Yeah, one I consider here. So one I consider what happened. I am moving from city 1 to 2. I can move city 2 to 3. Okay. Now from it is 3 to 5. Okay. Then 3 to 1 I don't need to consider. So I consider 3
No,
to 5.
3 to 5 also. Okay.
Yeah, 3 to 5 I consider, or 3 to 5 or 3 to 2 I have to consider. 3 to 2 I can't consider. It will violate. So I have
3 to
considered
4.
3 to 5. Pardon me?
So 3 to 4 we can consider it. 3 to 4.
3 to 4 is not lowest.
Even
As you see, 3 to
not
4
lowest.
is not
Okay.
lowest. You have lowest figures available here, 2 and 1, and already 0 is there.
Okay.
Okay.
Sir, excuse me,
Yeah.
sir.
Yes, please.
Sir, this is just a guesswork, sir, but I guess I don't know whether it will work or not. Sir,
Yeah.
here we have the positions of zeros and ones, no, sir. Sir, what if we, in the place of zeros, what if we replace all the zeros with ones and the vice versa, sir? So that you will get, we can reorganize the positions of zeros and ones, and after doing that same assignment problem, we could get those assigned the 0 positions, and the probability is more that we could form a closed loop, sir.
Try. Tell me the allocations here.
No, sir, but I don't know whether it will work or not. I'm just speculating, sir.
Okay, you can try. I'm not sure about it. Okay.
Okay, sir.
Yeah. So here, now what I can do is that I can just reorient it. Sometimes it will work. Okay. If I reorient it, it will work. That is, for example, instead of taking this 1 to 2, okay, I will say 1 to 4. What happened? One to 4. Okay. Then what happened? From 4. What is the 0 value lies there? 4 to 2. Okay, I have moved from 4 to 2. Then I have considered this 1 into problem. So by considering that 1 into my problem, I can move from 2 to 3. Right? Then already 0 is assigned. Already 0 is assigned over there. So I can move from 3 to 5. And then 5 to 0. Sorry. Five to 1. Will it violate any of the condition? So this is our original matrix. So I had the values like infinity. These all are infinite. I don't need to touch that. So these all are 0, 2, 0, 2, 0, 0. I have 0 here, 1, 0, 0. This is 2, 1, 3, 0. This is 0, 0, 3 and 4. This is 0, 0, 0 and 4. Okay, now what I told that instead of selecting the 0, I am moving from city 1 to city 4. Okay. So this I am. So when I select, automatically you can see that here the lowest. Okay. So this has been striked off. This has been striked off. Okay. So anyhow, the next highest I have decided to consider. So from 4, I am moving to 2. Okay, that is found to be the lowest. Now I have moved from 1 to 4 lowest. Then I moved from 4 to 2. Okay, so when I consider that these all options, this is striked off. This is striked off already. This is also striked off. This option is also striked off. Okay, I moved to 4. Right? Then from 4, I am moving to 2. Okay. From city 4 to city 2, I am moving. Now I am in 2. Okay. So this 0, I cannot. Okay. This also I can consider. Okay. But for the ideal case, I have already told you that I am going to select the next highest into my solution space. So I have chosen this option. Okay, 5 also you can try, it will not work out. Okay, that's why I'm not going to it. Now from 2 to 3 I have moved. Now I am in station 3. Station 3, I have 2, 1, 3 and 0. So 0 is for 5. So I choose this option. Okay. Okay. So when I choose that, this is strike off. Okay. Now I am in station number 5. So when I am in station number 5, okay, I have reached station 5. Now where should I go back? Where should I go back? I have to go back to city 1. Okay. In a minimum cost, did I completed the loop? Sometimes you may find alternate paths also. Okay. Please see the cost always. Please see the cost of assignment always, and lowest one only you need to produce. Sometimes two path may give you lower. Okay, that also will happen. So that also you need to think, and you have to act accordingly. So I have gone to page number 9 and to current page. So this is our actual problem given. So this is our actual data. Now from this, calculate the cost of assignment. So what will be the cost of assignment? So I have selected this 4. I have selected this 1. Sorry, 7. Then this is last is taken as 6. This 4 is taken into account, and this 5 taken into account. So it will be 4 plus 7 plus 6 plus 4 plus 5. How much? How much? So 26 hours. And this will be the final route. Okay. So this is what I got an assignment. Okay. So this is the assignment model. So that is not satisfying my traveling salesman condition. So I remodified the assignment in such a way that the minimums itself is taken into account. Okay, and find the lowest condition by considering the next highest value into the loop and solving the problem. So was this clear? So was this clear? Any doubts? Yeah, so we can see over here. So the same. So from city 1 to 4, 4 to 3, 3 to 5, and 5. Okay. So next non-zero element is considered, and we are proceeding to find the solution. So I'll give you a problem to solve. So try to solve this. Good evening. I hope I am audible. This is a problem. So salesman has to visit 5 cities A, B, C, D, and E. The distance between 5 cities are given in the so the salesman has to travel to the 5 cities A, B, C, D, and E. Distance between 5 cities are given in the table below. If the salesman starts from the same city, starts from city A and has to come back to city A, which route should be selected so that the total distance traveled by him is minimized? So here the first condition is given that this you have to please take into account. He has to start from city A. Okay. So starting city is given as city A. From city A, he should proceed to anyone, and after completing the loop, he has to come out. So here one condition is given that you have to please think of. The other problem that no such conditions exist, so you can have the freedom to start from any city in that loop, and has to continue, but that loop will, the same loop will work out. Okay, so quickly we will try to finish it together. We will first perform the row wise operation. So the minimum is 3 over there. So this will be become as 1. Is that so? That is 1. So the 1, 4, 0 and 1. B3 is minimum. So this is 1, 3, 0 and 1. Next one, 5 is the minimum. So 2, 1, 2 and 0. Third one, you will have 0, 0, 4 and 4. Here 4 is the minimum. 0, 0, you have 1, 3. Okay. So column wise operations. So first column, no change. It is 1, 2. It is 1, 1, 0, 0. This is 3, 2, 3, 0. Next is 0, 0, 2, 3. 1, 1, 0, 4. Okay, so we can try for the assignments here. I think we will have issues. Yeah, okay. So first is single 0. So the next 0 is striked off. This is single 0. We have to select that. Fourth and fifth is not that. Okay, this column is similar. Column wise, first two columns are not like that. This column we had only single 0. So when I select, these two is striked off. So any one of the option I can choose. So let me choose this option and let me strike out this. So one is unassigned. You have to add horizontal and vertical lines to this problem again, covering maximum number of zeros. Now you'll get the new table values here. So let me write infinity here. So 1 turns into 0, 2, 0, 0. This is 1. This is 1, 0, 0. You have 2, 1, 3 and 0. You have 0, 0, 3, 4. You have 0, 0, 0, 4, 0. We'll try to give the assignment. So first row, no single 0. Second row, no single 0. Third row, only one single 0. Given the assignment. So when that assignment is given, this is striked off. This is also striked off. Now the previous row also we had only single 0. The previous row is also have now single 0. We can give the assignment over there. When you give the assignment over there, this is also striked off. So if we see the first row now, the first row also becomes single 0. Give the assignment over there. Okay, so when I give the assignment, this is striked off, this is also striked off. So when I move into the fourth row right now, I had only 1 0. So select it. So this is striked off. Fifth also only, sorry, fifth also only 1 is available. So selected it. So assignment is over. So assignment is something like, okay, so assignment is completed. Now here the assignment model is completed. Now we'll check for the traveling salesman condition. Okay. Assignment completed. Check traveling salesman condition. What is the status? What is the condition? Now A to B. As per the case A to B, I'm going from A to B, then B to D, then D to A. Was it acceptable? Was it acceptable? Was it acceptable? No, that's not acceptable. So we have to consider the next highest figure into the problem we need to take into account. Okay, so the next highest is 1. So let us see by taking 1. Anyhow, A is final. So let me see 1B option I am seeing. I'll go from A to B. Yeah, A to B. Then so 1 is lying only in this B and C. So if I trying to take it further, so A to B some may not work out. So I will take A to D. Okay, A to D, then D to B, then this is not feasible option, then B to C, C to E, and E to A. Okay, so I have selected AD, then DB, okay, then BC, one I have taken into account, BC, then CE, and then EA. You can see every row, every column has only one assignment right now. Okay, then you can calculate the total cost of assignment. Okay, so total cost of assignment you can calculate from the first table. Okay, so A to D, D to B, B to C, C to E, and E to A. Total cost of assignment you can calculate from the first table wherever the question is given. So A to D is 3, D to B is also 3, then B to C is 6, then C to E is 5, and E to A is 4. So the total time is 21 hours. And this is your final assignment. condition only mentioned in the question is that we have to start from A, that we have met. Okay.